Good morning, everybody. I'm Dean Hintz from Save Software, and we're going to talk today about BIM Workflows and how to get BIM data in and out of CAD and GIS. And I have with me today both Leslie and Jerry from Concert Tech. If you guys want to just say a quick hi.
Hello. Good morning.
Yeah. All right. And so they've got a really cool project that they're going to talk about managing BIM through different information workflows. And I've also got Ken on the line from our European office, you could say. Hi, Ken. All right, so let's just jump right into it. So I'm going to give a few words of intro, then we'll pass it over to Jerry and Leslie, who will go through their project example. And then I'll wrap it up with a few more BIM examples, and then we'll have time for Q&A at the end. So basically, we're going to talk today about how do you build up a BIM system when all you have to start with is CAD data, and then we'll look at different workflows for integrating between different BIM, GIS, and CAD systems, and then finally look at some customer examples as well. And so basically, right at the top, we'll have a quick look at, well, what is BIM, and what advantages does a BIM approach give us? And then in a minute, we'll hand it over to Concert Tech. They have a really cool example built on an international airport project that they've done. So just a word or two about Concert Tech. They've been an important partner of ours for more than 10 years, one of our leading Canadian partners. And they're an expert in all types of data integration and management centered around geospatial data. And they have a couple of words, a little more detail when they get started. Of course, Safe Software, we love everything. We're the makers of FME, and we just love working with all kinds of data, be it spatial or non-spatial. And BIM 3D and BIM data is something that we've added support for more recently. And so really today we're going to see some ways of leveraging that power of how FME can integrate across all these different types of data. So just a quick overview of BIM. BIM stands for Building Information Model. And in terms of, well, what actually is BIM, sometimes people just think of BIM as, well, it's a 3D model of a building. Well, it's actually a lot more than that. It's all of the building information behind that. So it's not just the 3D representation. It includes things like dimensions and materials, all the different components that go into a BIM. And then there's different views and workflows associated with that. So, you know, the architects look at BIM from a design perspective, and then the engineers from actually building it, so the construction. And I think FME really offers some value in terms of how to move data between some of these different aspects of BIM. So one of the big challenges with BIM is the sheer complexity. So one building, you may have as much data in one building as an entire GIS for a small city. Now, speaking of GIS, a lot of us that come from more of a GIS background, that's really everything outside of the building. So you might have a building envelope situated on a landscape, and then all of the streets and the infrastructure around the building, and everything more from a geographic or map type perspective. And so perhaps you could say a significantly simpler, more relational, flat model of just features with attributes and geometry. So why are we looking at BIM? Why are people interested in BIM? I mentioned visualization is kind of the obvious application. You can also maintain and extract 2D floor plans for things like routing and maintenance. All sorts of analysis can be done with BIM for, let's say, green buildings and managing your systems scheduling, and then actually creating the building, constructing it, and managing it throughout the life cycle, facilities management, and updating it as you go. So as I mentioned, in terms of the challenges, Obviously, BIM can be a bit too complicated for a lot of typical GIS applications. So that's one big hurdle before you even get started, is how do you filter that down to something manageable? And then there's fundamental data model differences. BIM is very object-oriented versus the flat relational of GIS. And then there's a number of other challenges that we'll take a look at, things like georeferencing and schema mapping as we go. So how FME can help? Well, right at the top, we can help them manage that complexity. Typically, BIM software just exports either IFC, which is really super complex, or something simple like CAD DWG. So with FME, you can actually get the level of complexity and the information you need, and not the stuff you don't need. And quickly, just some of the type of formats that you might be involved when working with BIM, and how FME can integrate across those. So I'm going to hand it over now to Concert Tech, and I'll let you guys, Jerry, and Leslie, you're going to pick that up and tell us all about this cool international airport example.
Excellent. Well, thank you very much, Dean. So obviously I want to start by thanking Safe Software for inviting us on for the webinar. I just want to make sure that we could see everything properly. Dean, can you do a sort of a quality check just to make sure that you're able to see our screen?
I'm just making you presenter now, so
okay, great.
You should see a pop-up.
Okay.
Excellent. Okay, here we go. So again, just to double check, Dean, you can see our screen correctly?
Yeah, it all looks good.
Awesome. So I'll just do a very quick intro, sort of situate who we are, what we do. So we're actually based out of Montreal in the South Shore. And we have two main, I guess, fields of expertise, if you will. Of course, geomatics, ETL being one of them. We also have an AEC, or engineering, construction, architectural side of the business. And so what we've seen throughout the years that both marry very well, and this is where the whole BIM workflow came to, of course, be a very key point of interest for us as well throughout the years. We're seeing BIM being used more and more, especially here in Canada. I could even say specifically here in Quebec, we've seen more and more projects adopting the BIM philosophy, if you will. Again, BIM is very conceptual. So again, our core business, we have the two sides, the ETL, of course, extract, transform, load. We like to look at ETL to be able to create bridges between systems and applications. Of course, if we could automate that using a tool like FME, it's great for clients, of course, great for us as well. And of course, BIM being if anything, BIM is a process, right? So fully integrated process to manage models, to manage data, to manage documents. And of course, it's again, it's very conceptual, but we're able to use FME in many of our projects to alleviate some of that complexity. Again, just very quick overview of some of the work that we do. Open data being one of them. It's a fairly hot topic these days. Workflow optimization, of course, CAD GIS integration that we'll be getting into. Clip, zip, and ship data download, upload services, and of course, any type of process analysis and BIM workflows. So again, with SAFE, we've been partners with SAFE for almost 17 years now. Been a platinum partner for a couple of years. And long story short, our staff is definitely not only certified, but dedicated to upholding and using FME and promoting, of course, the use of FME. We love the philosophy at SAFE. We've adopted it ourselves here, and we hope to share some of that fun and expertise with our clients. So again, this is our team. Leslie will be the lead technical presenter for this morning, and what I'll do is I'll get straight to it. I'll sort of give the reins over to Leslie, and she'll be able to get into at least one or two of these projects that we worked on that include FME and, of course, using BIM.
Okay, so I'm just going to quickly go over my agenda, even though we already have an agenda. But very quickly, what is BIM? I'm just going to do a really quick overview to sort of set the tone, because the definition of BIM, I just want to make sure that everybody kind of like, for our example, are working off sort of a common idea. Client context. I'm going to explain a little bit of the history of this client and what it means first step towards the BIM. So this is a client that started with nothing but 2D CAD plans, and now we're moving them to BIM. And most of my presentation is going to be about these first steps for that, and then I'm going to kind of talk about what we want to do after and sort of our experimentations and towards of where things will go after. And then I know that Dean will move on and talk about more things to sort of set the tone for what can you do to integrate with different kinds of BIM data. So, okay, so I just grabbed this graphic here. There's like 1,000 graphics out there of like the BIM circle. I'm sure that a lot of people here have maybe seen it in the past, but I just want to make sure. So the idea of BIM, okay, so BIM meaning building information modeling, is the concept of using a model-based approach for the building life cycle. And building can actually mean more than literally a building, okay? It can also mean applying the concept of information life cycle and model-based design in, for any of the kind of components you see in this circle. So actually, you can apply the concept to doing road design, and then road construction and any of the infrastructure. So, sometimes we hear people coin a term BIM for building and BIM for infrastructure because they're applying the same BIM concept. And so we'll see that in the case of an organization like an airport, actually all kind of pertains to them. So the BIM life cycle here we see is, we have the, preliminary design phase, and here we have the plan. So, here we're planning what we're going to do. Then, actually, the circle goes counterclockwise. And then, we do design. Then, things get actually constructed, and then we take the information and we bring it into a management phase. So the idea of being able to, carry the information through the life cycle so that it's not constantly re-engineered at each phase. So we're not always starting from zero, as the civil engineers and as the architects and as the different people involved in this cycle, come into play. So I'm just for the purposes of this presentation, I've kind of divided, and we're not going to talk about all the tools of BIM. I'm using the Autodesk ones here because actually that is what the client I'm talking about today is using. So the three categories, so I kind of made a category design tool. So if we think of Revit and Civil 3D, so two tools that people use for designing at the design phase, doing engineering calculations and stuff like that. Then we have the integrators completely on the other side of this, and the integrating tools, like I'm going to use Navisworks and InfraWorks. So these are tools that actually integrate data from different sources and different places, and people will use that to, make decisions, do some, clash detection in the case of Navisworks, and do some, at the planning phase, in the case of InfraWorks. So in InfraWorks is really where you'll see an integration of GIS-based data with, civil engineering data, with actual building models, and, you kind of get this, like, whole view of what you have from a higher level. And then you have the one in the middle, which is information management. So to be able to complete that circle, you need to, have a living inventory of your information that you have. So that is where you see here. Well, that's what in, my story here is the role for Map 3D. So basically, that's the GIS component. So the idea that, things cycle through the system, and then we sort of have an inventory in the GIS. So the GIS captures some, data about, assets and stuff like that. And then we have Vault that plays an archival role where, all the plans and stuff that are developed through the cycle are archived into Vault. So I think Dean said it before, an airport is kind of like a city. They actually manage everything on their grounds. So they actually manage everything from their real estate, their buildings, their facilities, but they also manage all of their infrastructure as well. So they actually manage everything from their aqueduct to their sewers, to their roads, to their electrical. And then there's, on top of that, you know, some components that are really airport specific, like runways and then runway lighting, for instance. That's really specific to them. So they're kind of like a mini city, and they really actually have as much data and infrastructure as a city to manage on a smaller scale, but it's a lot of information. So what this particular airport had is they manage all of their infrastructure and their buildings. They had a huge CAD inventory, and all of it was in 2D. And they were using, to manage these documents, they were using Sharepoint to manage their plans. But Sharepoint was causing them some challenges because it's not really CAD aware in the same way, and they were having trouble, managing certain items. Like for those of you in the audience who know CAD, managing references and stuff like that in drawings, and they weren't managing versioning either on plans like they have. So, and one of their other challenges was actually there are many departments and professionals and people who need access to information. So they need to be able to cycle this information through, everybody from the architects to the civil engineers to the structural engineers, and even to people in, operations and maintenance and security. You know what I mean? There's a huge number of people who need access to this information. So their objectives for BIM, they sort of wanted to apply, using BIM in two places. So they wanted to apply it both for their external construction projects and for their internal management. So what does that mean? What it means is they wanted to, when they're dealing with outside firms who will do either design or do some infrastructure work for them, they wanted to be delivered 3D models in the future. But to be able to do that, they sort of have to be ready to receive that kind of information in-house as well. And they also wanted to do their internal management because of course they manage their infrastructure, so they needed to set themselves up internally as well. And in the long term, their objective is to be able to integrate with their asset and facilities management solution, which for them is SAP. So what are the challenges that you face in this sort of thing? It's moving data into different systems. So there's two types of ways to see that. One is taking them out of their original 2D world and moving them sort of up the chain in terms of models. And then the other is, in the future, as they start to use more, model-like based data, and as they use like GIS data and these different things, they need to be able to continually keep cycling data throughout these systems and these different applications. So that's where FME is going to come into play. So it's both into the migration and then the sort of integration of different systems. So this is sort of a graphic that I kind of threw together to sort of explain, because the two facets that I'm going to talk about with FME and what they've done is sort of getting out of the the 2D infrastructure management. So infrastructure meaning their all their electrical and cabling and all that, and as well as sewer and everything, into a GIS, because they realized that in order to be able to kind of have that shared information and that shared inventory and be able to spread information across the organization, it wasn't a question just of implementing and using Civil 3D or using Revit. They're actually going to need a GIS as part of that workflow. And then they actually decided to go with Vault for their document management system. So the idea is, if you look in this cycle, you're going from plan to design to construction, and then once the data, once you have some new as-built stuff, then you can branch into manage. So you can branch your data into your GIS and also branch your data into your iCloud system, and then the arrows can come back up to the top. Now you have your basis. You can work in InfraWorks or some 3D, high-level 3D tool to do your planning, and then you go, to your design phase. You use Civil or Revit, depending on what kind of design we're talking about. So that's the idea, is using the BIM kind of workflow. So like I said, building information modeling for them, meaning more than just the buildings, actually building things, building any kind of infrastructure and assets. So the first one I was going to talk about, where we have some interesting examples of FME, is actually simply CAD to GIS, which is very like original thing. So what they had is they had all of their plans were originally in 2D CAD master plans. So basically they would have, for a single network, they would have a CAD plan, a CAD drawing that, you know, somebody keeps editing to keep it up to date, but they have no intelligence data associated with that. They're not maintaining like 3D attributes that would allow them to reconstruct 3D data out of that and stuff like that. So the GIS implementation kind of looks like this. You know, SQL Server Spatial was chosen as the database platform. They're using AutoCAD Map to do editing. They're using, and then FME, the role FME played was in that original migration, so going to and from CAD and Civil. So the idea is they can pull data back out for, you know, doing civil design. They can pull data back, you know, they can pull data back out for other reporting purposes. So, you know, they can create reports and information on their assets, which they weren't able to do before very easily. So this is like a big plus for them. And they'll be able to, you know, connect in eventually to their asset management system. And so these are the roles where FME can play for them and has. So in the migration itself, you know, FME was used that. So the way we do like CAD to GIS migrations is we'll use FME at 3 different places, and that's what we did for them. So we'll use it to do analysis, so pre-conversion steps, the conversion itself, and then we actually use FME to do the QA. Because when you're moving data in, you want to make sure that you know what got in, how many features didn't get in, and all these sorts of things. So that's what I'll sort of show some bits and pieces next. So in the analysis phase, FME inventoried each drawing. So actually we used FME to pull out what were the layer names, what kind of objects were on each layer, how many were there, you know, what types they were, lines, text, blocks. And so the exercise here is we produced Excel spreadsheets, and this is where the users kind of see, hey, wait a second, we have this extra layer we didn't realize was in there, or oh, there's a typo in that layer name, and you know, because eventually the layer names themselves will serve to feed the attributes to start the system. So actually, people, what they do is you know, and then what happens is that while we move into conversion, sometimes they clean up some of the data in some cases because they realize, oops, there are some text objects on this layer I thought I only had lines on. So the outcome of the conversion is ultimately going to be better by doing this first. So then, you know, we move into the conversion phase. So this is an example of one of the phases. It's pretty simple in general conceptually. So we read the layers from the drawing. That's what we see at number 1 on the side. Then we did some angle and text checking and matching some attributes by proximity, so I'll talk about that in a moment. We prepare some general attribution we want to send into the database. We send the data into the database. But at the same time, we sort of capture counts of features and do some analysis, and we put some reporting out to do some QA. So what are some of the conversion challenges we faced by doing the conversion here? Attribute mining based on proximity, matching text values to a domain value, and keeping the data freeze short. So I have some slides for the attribute mining stuff, but the data freeze short, keeping the data freeze short, one of the challenges is that, you know, an airport is always moving, it's always developing, things are always happening. Like they can't put their data on hold, you know, for very long. And depending on which network we're talking about, some of it is more critical than others. So they're like, we can't freeze our data while the conversion happens for like a month, you know. So what we do is, while we're simulating the conversion, they keep editing their drawing. And at the last minute, because FME, we're able to rerun the conversion, and it's very quick, we're able to then say, okay, you know, take the last delivery, do the last changes, and then keep the amount of you know, modification they need to do. So keep that period that, you know, between the start of the conversion to the end of the QA and then delivery of the data as short as possible. So, and then by doing that, in a cyclical fashion, we're able to, keep the data free short on certain important data sets. So one of the challenges was angle calculation. So if you look at like the line on the left, we see that, okay, so we have a pipe and it's 200 millimeters and it's made of PVC. So one of the challenges is that sometimes the text value is actually physically closer to the line over that it's connecting to than it is, to the line we want to connect it to. So one of the things that we do in that case, is we actually used the angle of the text and compared it to the angle of the line to give ourselves a much better measure. So to explain how that works in FME, so what did we actually do to do this? We actually use a chopper and break the line, because some of the lines actually have multiple vertices, so the line itself changes direction. So what we actually do is we chop the line up. So and that's a nice thing with FME. You can break apart the data at one point, but carry the clean line through another direction. So we use the azimuth calculator. So that's one that we download from the FME store. So as I always tell people when I'm giving a training, always good to check the FME store and see if what you want already exists before you start to code something similar to like an azimuth calculator or something that has obviously some sort of calculation behind it. Then we use a neighbor finder here, and then we're actually like trying to find the closest text. And then after that, we're doing a check. So we're using the neighbor finder, so we're using a tolerance to find text close to it. But then we're also validating that the angle of the text is similar enough to the angle of the line that it found. And if it doesn't match, we actually reverse the rotation of the line, because sometimes the text and sometimes the line's actually going in the opposite direction of the text, so we actually do a second check. And this sounds like a lot of steps, but we actually found that it gave us a really reliable way of making sure we really had clean data at the end and we really had good information. And the same exact technique, we've actually applied it in multiple projects. And actually what we found is, so now we have like two tolerances. So how close does the angle of the text has to be, and how close does the text itself have to be to the line? And by using the two, we're actually able to simulate a few times, and then you kind of find the sweet spot for those values and figure out where you get like the most bang for your buck, like you get the best conversion possible. So like I said, we actually reuse the same technique in many CAD to GIS type of instances, and actually gave pretty good results. And then another challenge was the domain stuff. And so in the domain, so what happens is that we want to capture that pipe is PVC and associate with an attribute domain in our database. But of course, since it's CAD, the PVC could be written any kind of way. So what we do is we use FME, and so this is where the FME becomes really useful, because we're able to do some text cleanup and get the highest matches that we can, and then those that didn't match, we're able to identify them, and we're actually able to feed them into a separate attribute that the user can then clean up after. So then we don't really lose the information in that way. And so that's what's nice about FME. We're able to clean up, get the best result we can, but we're able to actually compensate and know what didn't work out. And that's actually, I think, one of the best things about using FME for this sort of thing. And then at the end, we did a quality control. So we validated the counts of features that arrived in the database against the number expected. So what does that mean? That means that we were able to calculate in a report what the percentage match was. Now the other thing we are also able to do from this is able to deduce actually, we actually make a shapefile as well. So one of the only things I'll say is that if you do the same thing as us and you use FME to do reporting and validation, you need to think about what you want the report to look like for the person who's going to have to make corrections. So this is more of a high-level report, so it's good for having an idea of how it went. But for the person who's going to make the corrections, we made a shapefile with the information that was missing, and as they pan through and add the information they need, they kind of eliminate the objects in the shapefile, so they're able to kind of see where they've got to and see what they have left to clean up. So you really have to think about what that means for that. So the benefits of using FME for this: restructuring, validation reporting, and able to simulate the conversion. What's next? So now that we have everything in the GIS, so this is another project of a client that's actually a little bit ahead in the game on that. They already have a nicely designed GIS infrastructure with the information they need, and FME was, instrumental in helping them be able to set up, InfraWorks. So they also use SQL Server to manage their infrastructure data. It's a similar type of client, a client that manages all of their own infrastructure, including buildings and pipes and everything. And what they do then is they're able, if you can see in the graphic on the left, you see that all that underground infrastructure that's coming from the database, we're able to simulate the 3D. So if you build a good GIS that captures all that information you can get from civil, for instance, be able to get the pipe diameters, the inverts, you're able to rebuild that sort of pipe structure that you had in civil and 3D. In this kind of view. So where does FME serve in a tool like an integrator like InfraWorks like this is that a lot of the time InfraWorks, you want to go get that larger, broader scope, so you're getting a lot of GIS-based data, you're getting a lot of different models from different kind of applications, so terrain, some city GML, some FBX, but a lot of that stuff has to be refined to be able to bring it into InfraWorks. Like InfraWorks will connect to some of it directly, but some of it has to be tweaked. Like you want to clip it, you want to purify it, you want to reduce the amount of data. So the next one is the Vault Document Management System. So for that one, so this is where FME was also used in another migration, and this migration was purely non-spatial. We actually used FME to migrate their Sharepoint document management system to Autodesk Vault for management system. So FME was actually quite instrumental in this thing. So just to share, so why they were implementing Vault again, they have many people who consult the plans versus the number of editors, and they already had in SharePoint around 40,000 plans that were being managed. So the idea of automating this migration was really important. So very quickly, I won't go through all of this in the interest of time, but in the SharePoint database, the files are actually stored in the database as blobs. So I actually used FME to extract the files from there, write it to a file system, and then we actually loaded the metadata that we pulled out from different columns, so in the SharePoint database, and to feed the Vault database. So basically, very quickly, we extracted the files themselves, wrote them to a file system you see here on top. At the bottom here, FME also was used to write a temporary file in FME's format, an FFS, which was then pulled into another FME workspace that actually restructured the info and sent it into Vault. So very quickly, this is the workspace extraction. So we were able to, here we're reading at the beginning in 1 and 2, we're reading the data from the database, so literally reading the files, and we're reading the XML metadata. Then we're actually building the data extraction. At the very top at 6 and 7, we're actually writing the file structure. So they want to maintain the same file structure, so we had to reproduce the file structure that they had in SharePoint and reproduce that, and then some reporting. So that's one of the nice things, again, about using FME. It's always that beautiful idea of being able to have a measure of how things went. So then they used FME again. So then we used FME again to do that second step. So this is just that second step. We're reading that FFS of all the metadata that we extracted. Then we're connecting to the Vault database, and here we're using a lot of queries to push the appropriate data into the appropriate tables into the Vault structure. So we're talking about one database structure to another, one that stores the files, one that connects to a file system. So very different philosophies, basically. So benefits of FME for the Vault implementation: we were able to deliver a turnkey solution. So we were able to, get them from the ground up into Vault very quickly this way. We avoided the manual loading. We could minimize the risk by manual loading, and the translation could be simulated. So again, the idea that you can simulate what you're doing, it can be re-simulated, it can be adjusted as you kind of figure out what you need to tweak. I think that probably remains one of the most important things. So what's next with BIM? So once you build your basis, there's several ways that we can use FME. So based on certain like experimentation, so going towards InfraWorks is definitely one of them. So getting that kind of full scope of, you know, all of your infrastructure, getting your buildings, getting your infrastructure, and then you have to get a whole bunch of like city data around that to sort of, you know, you don't want to just have your airport and it's kind of in the middle of, you know, in the middle of space. You kind of want to see a little bit what's around it. So that's the idea that, you know, you're going to integrate information that's going to come from the outside as well. And then interoperability between the different BIM tools as well. So I talked about their infrastructure, but they also manage their buildings. So prepping data from InfraWorks, I already mentioned that one. Extracting data for civil design phase, I already mentioned that. So that's on the InfraWorks side. But then there's also the building side. So this is not one that we've actually done for them, but this is what we're experimenting with for our BIM type clients who you know, who have to think about, you know, the facet of managing things over time. So this is an example where I have 2 Revit files and I'm actually doing some change detection, and actually I can kind of see like the 2 models you see on the right are what FME outputs in the added and deleted, and I can actually see that it's actually pulled out that wall that has a door, and it's showing me, you know, the new version of the wall versus the old version of the wall that didn't have the door. So actually it did actually do a pretty good job based on what I'm seeing here. So that's why, so since last year we've been sort of, you know, trying to move into, you know, if we had to integrate, you know, different you know, Revit files together, what might that look like? So this is not actually the client's BIM model. This is a generic BIM model, but we have to sort of solve the problem of, you know, how are we going to detect changes? Also, if we want to use InfraWorks, fully equipped Revit models are usually too heavy, you know, to export everything. I mean, we've done some experimentations, you know, but sometimes when you have the tables and chairs and the doorknobs and, you know, the, you know, hinges on the door and everything, you know, the model is just too heavy because it's not the focus of InfraWorks. InfraWorks is for the big picture of things. So, you know, we can extract, you know, we can get simpler models out, and then, you know, have sort of like lighter 3D models that we can use for different pieces. So that's another way that we see FME playing a role probably in the future of this. So these are not things that we've actually implemented for this particular client yet, but this is where things are. This is what we're looking at right now in terms of like how are we going to, you know, do a long-term maintenance and stuff like that, and just different ways that we could eventually use this information. So I think that pretty much, I think I've pretty much kept on time, Dean. If anybody has any questions, this is my information. I believe SAFE is going to share the slide share on their normal slide share system, so people can feel free to contact me if they have any questions of any of this sort of stuff.
Yeah, thanks a lot, Leslie. That was great, and also for Jerry for the kind of company overview. So yeah, that was really cool to hear all about you know, how that Concertec project at the airport, and how you guys have managed to build up that whole information system just based on the existing CAD data and Sharepoint data, and building up the SQL Server Spatial GIS and that Vault database. So and also some of those next steps. The next steps that you've talked about in terms of building up the BIM and building up a little bit more of the 3D capabilities. That's kind of where I'm going to take this next. And you guys can see my screen there, okay? Just have a quick look here. All right, so I'm going to look at a bit more broad level in terms of how can we go from, once we've got GIS, how can we use that to load BIM? So getting data into BIM and then out. So we don't have tons of time. We've only got about 15 minutes or so to go through that, and then we'll have a bit of time for Q&A. But I thought I would highlight a few things that were just key aspects of moving data in and out of BIM. So as I mentioned earlier, there's sort of fundamental differences between the GIS and the BIM data models. So often there what you need to do is a lot of schema mapping resolving relationships, there's all those linkages in the BIM object. So if you've got a room within a building and then walls within the room, all of those kind of relationships have to be resolved before you can write out that building record. And the other thing we find can be often challenging is georeferencing. So a lot of these BIM models are not located spatially on the Earth's surface, and so you need to make sure you've got a reference point that coincides with a survey position, so that can be referenced. And we've got examples of that online that you can look at later. I did notice in some of the questions that have already been posted that the 2D to 3D process is of interest, and so I've got an example I'm going to pop up in a second that shows one way to do that. Certainly converting 3D data and extruding. FME supports, if you just go to safe.com/formats and you choose 3D, you'll see we support 30-odd 3D formats. So we can bring in the 3D data from wherever you might come from, be it City GML or Collada, SketchUp, what have you, and then load that into your BIM. And then there's lots of other aspects of BIM data in terms of how you style the appearances and then the validation. I think Leslie did a great job of showing some examples of how to validate data, bringing it in, because there's no point in bringing in stuff that's not going to make sense in the model. So just a quick footnote here about some of the formats that we support related to BIM. There's a lot more we could talk about, but these are sort of the highlight, the standard ones when people talk about BIM are IFC and Revit, and then there are sort of some BIM light, you could call, formats. If you get highly detailed City GML or Indoor GML formats, that can be useful for data exchange. And here are some key techniques that we've noticed are really important when working with BIM data. And I don't have time to go give you examples of all of these, but like I said, there's lots of resources available. Just to start with, because FME can read and write things like IFC, you can actually use your GIS if you're coming from a GIS perspective. And in the case of Leslie's project, they've built up all this data in the SQL Server Spatial, so you can use that as a starting point for what is called a slim BIM. And so I'll show you an example of that in a minute. Another interesting workflow is using FME to maintain and update your BIM data. And so if you're more comfortable, you've got analysts that are more comfortable using Excel, they can make edits in Excel and then use that as the medium for providing updates. Obviously, generating data views, that actually reading Revit using the data views, that's really key. And again, I don't have too much time to go through a lot of examples of that, but the data views really do a lot of the heavy lifting in terms of filtering the data down just for what you need. For example, if you just want spaces, you can choose spaces and that's all you get when you're reading the data. Filtering the data, I've got an example to show you there, and managing these complex hierarchies. And one way to do that is with what we call geometry X-query or G-query. So we'll come back to some of those key techniques in a minute. So right now, I just want to show you a quick example of what happens if you've just got CAD 2D data, and then some people were asking, how do you convert that to 3D? So I'll pop up a workspace here, and so you can see we're just reading this this AutoCAD real DWG data, and we're writing this out to IFC. And so this is basically going, whether it's going from CAD, it'd be a similar process if it was reading from Geodatabase or SQL Server Spatial. It'd be the same basic problem. So the key thing here with the geometry is that we're just extruding. So you can see the key information we're getting from the data source is the height. And we've also got a name, which is actually an ID number. So those two things are critical to have for the destination IFC. And so the geometry part's fairly straightforward. We create some some of the required attributes and set those as traits. So when you're dealing with IFC, everything gets set on the geometry as traits. Now what's a trait? They're basically attributes that are embedded within the geometry. And given the complexity of the IFC structure, it's sort of beyond the scope to explain exactly how that structure works. But just to suffice to say, you've got to develop the right structure in order for the writer to be able to generate the output model and for it to conform with the IFC spec. So that's the extrusion is what gets you the 3D geometry, and then we have to build up the property sets, and that's done by removing the geometry and then defining these property values based on things like the name. And then we actually, even though we don't have any geometry, we use the geometry property setter to build up those traits based on the property sets, and those get written out. And we don't just write out the property sets, there's also a property set definition. And I'll just point out, and again, there's lots of documentation available on this. You can, you need these special IFC transformers, and so if you just type IFC on the canvas, you'll see that there's these IFC property set definition creators, which do a lot of the work in the background. You don't have to understand all of the details of the format. Those are designed to support writing to IFC, and so it has a list of applicable or acceptable data types, for example, or values. So that's just a little bit. These workspaces will be available for download. You can play with them. I'm just going to go ahead and run this one again and then show you what the output looks like. And again, we're just going from those 2D CAD drawings over to IFC. And just to satisfy people that we're not just viewing everything in FME, so that this actually can work in an IFC viewer, I'll open it up in Solibri. This is one of the more commonly used applications for viewing data. And you can see here that we're bringing across all of the details of the data model, including, what was I going to look for here? In this, here's the lobby. So all this description of the IDs and the use of the room and all that sort of thing, room number, things like that. So there's just a quick example of going from 2D to 3D using a slim BIM approach. And we're basically just writing spaces, as you can see here, but it's a good starting point. If you were going to try to build up a BIM, you could start using that for scheduling your rooms or routing between rooms, perhaps. Just looking at your overall inventory or how much volume of air you need to heat, that sort of thing. And then you could add to that over time. Okay, so that's what the same thing looks like in FME's viewer, and you can see we give you a detailed view of all the IFC properties and geometry components there. And so yeah, key takeaways, you've got to define the IFC property sets and their definitions, and you can get all that generated from GIS. And using Dave was kind enough to put together that workspace, and that's a good starting point, and there's some great tutorials on this on our knowledge base. So another quick example before we wrap up, and this is something that I ran into on an I-35 demo project that we did about a year or so ago. And this is a typical issue with BIM where you've got tons of information. So there was something like in the neighborhood of 25,000 different rivets, so not rivets, but rivets in this model. And I found that when I tried to write this, for example, to when I tried to write it to something like CityGML, I had more than a 2 gig file, and things got really slow real fast. So what was critical here was figuring out how to filter that out, and that's often the case when if you're going the other way now. So let's say you built up everything in the BIM, you want to come back to GIS or extract stuff into Excel for other uses. How do you filter out what you don't need? And so I'll just pop up that workspace just a sec here. So one approach to doing that here is we're actually calculating the volume, and we're using this little bit of X-query. You don't actually have to know how to type all this stuff. Basically, you just choose, when you play around here, it changes the expression. I'm not going to accept because it won't run, but yeah, basically all we're saying is if there's any component that's of IFME extrusion, calculate the geometry at that point. So we don't want just the total geometry of the whole object. We want the volume of all the individual components. And then basically for anything where the volume is bigger than about, I don't know what that is, 5 by 5 centimeters or so, anything smaller than that, this was the right number that helped us get rid of all of those rivets. So I'm actually going to go ahead and run this, and you'll see how long it takes. So this is something that if I didn't filter it out, I would like to demo it, but I don't have time. If I didn't filter out the data, this probably would take, 25 minutes to run or something. But by filtering out all those tiny little components, it processes fairly quickly. And so that's really one of the key things is when you are designing a workflow, reading from BIM, how can you filter out what you don't need and just zoom in on the parts that you do need? And when you're reading from things like Revit or IFC, understanding that data model and knowing, okay, I need just the spaces. That's one approach. I'll just zoom in on the bridge here just so you can see it. And this is just using the data inspector, which we've put a fair bit of work into to handle the 3D. So you can see there's all the detail there, but without the actual rivets on those plates. And actually the plates themselves, that's one of these plates is what failed and caused the bridge to collapse. All right, so just going to wrap it up here pretty quick and then have some time for Q&A. Yeah, just a quick footnote about the bridge demo project. That was the Revit model was created by DBI architects, and there is the Revit extension, which is actually free, by the way, so you can download that from safe.com. And that anybody who has Revit can use that to generate an FME export. And then we converted that data to City GML, which was loaded by Virtual City Systems into their 3D database. And then our friend Alex Carmen over at RevMac, he did some downstream analysis using linked data tools, and there's a webinar on that you guys can check out later. That's what it looked like in Virtual City Systems environment. Okay, well, we don't have time to go through that workspace, but this stuff is all available online if you're interested. One or two quick footnotes, and then just wrapping up here. We do have a very powerful geometry validator for 3D. Well, this handles both 2D and 3D data, but I've selected here surfaces and solids, and you can set things like tolerances. And so if we did a project with the OGC on looking at City GML validation, but this could be applied for any type of validation. And so if your CAD data or GIS data is not that clean, and then you go and try to extrude those into volumes and solids, then you can quickly find things like walls missing or different types of fragments which will not be valid for loading into a BIM. And so catching that with the validator, there's even a repair option there which can help clean up your data. So there's lots of detailed reporting where we annotate the geometry when there are problems, and you can see exactly which features passed or failed. And then lastly, just a quick footnote about publishing data. So this is sort of a whole other topic which we don't really have time to get into, basically, you can stream out once you've got your data in BIM, you can then use FME Server to serve that data out to things like 3D PDF, KML, and then we're looking at WebGL type methods of rendering data to support even mobile devices. So things like 3JS, X3D, Cesium, or you can just put your data out there on S3. And yeah, that's a cool, the S3 is a great environment because you don't have to worry about the linkages. It's like a sort of a virtual website. Any data you put up there, all the links get resolved, and you can serve it fairly seamlessly. So a quick footnote on success stories, some other customer success stories which you can read about online. The Mount Vernon HBIM was a project that Esri did, and we supported with the FME exporter and data interop. And that's all about, leveraging the value of BIM by providing this rich context. So BIM's all about buildings, but in order to get value out of that, placing that building on the Earth's surface and giving it the context using things like LiDAR and imagery in order to do viewshed analysis, for example. And then the University of Washington example is very interesting. That's all about, that's a complete BIM application built on CAD where they are doing things like room scheduling, the space inventory, routing, and that's fully integrated with their enterprise admin, operations, and maintenance. So that's a very good one to check out. And then we've also done some work with HOK. They auto-generated about 2 million buildings using FME. So that's obviously not super detailed buildings in the nature of what we're talking about today for 1 or 2 buildings having, but basically still, that's very rich 3D representation of a whole like cityscape. So just to sum up, as we're pretty much out of time here, BIM is all about information management. So you might think of BIM as just another cool 3D tool, but really, as Leslie talked about that great example with that international airport, it's all about managing the information throughout the life cycle, right from planning and design through to maintenance and operations. And I think that's really where the value of BIM is leveraged, is when you're not just, it's not just sitting on the shelf collecting dust after design, but it's integrated with the CAD and the GIS systems, and that's something that FME can really help with. There's been some big barriers to getting data out of BIM and using it or loading data in. And so given FME's power of working with all the different CAD, GIS, and database formats, you can get the data in and out that you need. You can do the transformation and validation just to make sure the data makes sense and is accurate. And we can support extraction and filtering, so you get just what you need on the way out. Automation is another key aspect. We didn't really have time to demo it, but certainly Leslie's example, they automated the processing a lot of files and built up some business rules around that, and then publishing data out to client-friendly formats via FME server. So there's lots of potential there, and that's kind of what's coming in new development. Next steps in FME is making more of those sort of web and mobile-friendly formats easier to support. So there's the webinar, past webinars, FME training, lots of blogs, and yeah. So I just wanted to thank Leslie and Jerry from ConceptTech for their great presentation, and also to Robin and Stephanie in the background. They're managing this webinar, and also to Ken for his support. And so I don't know, Ken, do you have any quick questions there?
Sorry, I was just muted. One interesting one, Dean, have you ever seen anyone move BIM data into Minecraft?
Yeah, absolutely. I know Dimitri did an example on that last year. So if you look at the last year's webinar, it was sort of in the overtime slot. So if you scheduled to only watch the webinar for 1 hour, you might have missed it. But in the overtime, he has this example. And again, you'd have to go to, actually, if you just go to, how do I get out of here? If you go to safe.com/BIM, that will resolve to this link, and there's a link to this webinar from last year. And at the very tail end of that, there's loading BIM into Minecraft. So that's a great example of that. But yeah, good point. That's a great way to sort of a mass market way of interacting with 3D and BIM style data. More just from sort of a fun gaming approach, but it's amazing how many people will use that in different applications. Were there any questions that came up? Again,
I think you did a good job, yeah, covering sort of the creating 3D geometry from 2D data. That was a question a couple people asked, so we covered that well, thanks.
Okay, and I just wanted to point out here, I have these links already open. If you go to our Knowledge Center and you just type the word tutorial, there's a BIM tutorial that comes up that Dave's put together, reading, writing from IFC, and then there's a 3D one that I did, which deals with kind of going from BIM to other 3D formats like CityGML, SketchUp. So yeah, I mean, this is one example of that, where you actually get in the 3D PDF. This is something that could be streamed out by FME Server, for example, to any web client. So yeah, there's quite a lot of examples online that you guys can check out after the fact. So
sorry, Dean, another question about, I know you have a lot of experience with, someone asked about the difference between IFC, how it models data, and CityGML. Do you want to talk about that for a minute, or are we out of time? But anyway, that was the question.
Yeah, I can just, for 1 minute, and we can always follow up in more detail later. I mean, IFC clearly is, you get down to, if you're looking at a room IFC, you might detail every single little handle, the thickness of the door, the material in the middle of the door. Typically CityGML, the CityGML, I'll pop up an example while we're talking. Here's some CityGML. This is converted from IFC, and that's LOD2, I believe, and then I can go to LOD3, where you've got a bit more detail. But when we get inside the building, you know, that's kind of, okay, there are some spaces in there, there are some columns, but, you know, most CityGML models I've seen don't really get into the information management of a building itself. So when we're talking about BIM and the kind of stuff that Leslie and Concertech were talking about, most people don't use CityGML to manage, you know, every item of furniture, for example, or every all the different materials. And so I would say CityGML, like, is well named. The main focus is kind of the city space, the cityscape, and then with BIM, or with, you know, IFC, really, people often, you go to conferences and sometimes people complain and go, well, BIM is more than just Revit. Really, IFC, a lot of people would argue that IFC is interchangeable with BIM because it's the main open standard for building information data. So obviously, for exchanging between BIM and GIS, CityGML can be a good tool because it is fairly comprehensive. It gives you a lot more. It is object oriented, so you can have all, you know, data down to the room level and move that between different applications. Okay, I think if there's no other questions, I'll just pop up the last slide there, and you know, Stephanie will make all of these slides and a number of the demos available. We'll probably send out a mail out, and it always ends up on our safe.com/webinars page. So again, I would like to thank Leslie and Jerry from Concertech for a great presentation, and also Ken for his support on the Q&A. Thank you all for tuning in, and you know, don't be shy. You can always go to safe.com/support. I will point out, I think the FME store was mentioned, we're calling that FME Hub now, so there's lots of great tools there, and if you go to safe.com, on the support link, the knowledge base there's a lot of great articles. We're trying to develop not just nifty, whizzy examples on our knowledge base, but also very practical tutorials that kind of model workflows. And there's also, under the knowledge base, there's room for your ideas as well. So we always welcome your feedback. So yeah, thanks again for your time, and we'll hopefully hear from you all soon, and perhaps on the world tour. So don't forget about the world tour that's coming up in about a month or so across the U.S. and overseas as well. Thank you very much. Bye-bye.